The air on the construction site was thick with anticipation. A massive, gleaming air conditioning unit, the size of a small bus, was suspended 50 feet in the air. It hung from the hook of a towering mobile crane, a silent giant against the blue sky. The crew below moved with quiet purpose, their eyes fixed on the load. The plan was simple. Lift the unit, swing it over the half-finished roof, gently lower it into its designated housing. Everything had been checked. The calculations were done twice. The rigging seemed perfect. For a moment, it was a picture of perfect industrial harmony. But then a subtle shift occurred. A gust of wind caught the flat side of the unit. It began to sway, just a little at first. The movement was almost imperceptible, a gentle pendulum motion. Down below, the signal person held their hands steady, watching. The crane operator, high in the cab, made a tiny adjustment. But the sway grew, amplified by the long length of the crane's wire rope. In the world of cranes, silence is often golden. The roar of an engine, the noise of a busy site. The distance between the operator and the load make verbal commands impossible. This is where a special language comes into play, a visual conversation that ensures safety and precision. This is the language of hand signals. Standardized across the industry, these signals form an unbroken chain of command from the ground to the cab. The signal person is the eyes and ears of the operator. To tell the operator to hoist or lift the load, extend your arm with your forearm vertical and your index finger pointing up. Make a small circular motion with your hand. It is a simple, intuitive motion. Up, up, up. To lower the load, the motion is reversed. Extend your arm with your palm down and your index finger pointing toward the ground. To swing the boom, extend your arm out horizontally and point your finger in the direction you want the boom to travel. For a normal stop, extend one arm with your palm down and hold it steady. For an emergency stop, extend both arms horizontally with your palms down and swing them back and forth rapidly. To truly master lifting, one must understand the machine itself. A crane is not just a hook on a rope. It is a complex system of interconnected parts, each with a specific and vital purpose. On a mobile crane, this includes the outriggers. They are placed on firm ground, often with pads or mats underneath to provide a wide, stable base. Without properly deployed outriggers, a crane is like a person trying to lift a heavy weight while standing on one foot. Moving upward, we find the boom. This is the long, powerful arm of the crane that does the lifting. Booms can be telescoping, meaning they extend and retract in sections, or they can be lattice booms, which are fixed-length structures of crisscrossing steel. The boom's length and angle determine the radius, which is the horizontal distance from the center of the crane's rotation to the center of the hook. A longer radius means the crane can reach farther, but its lifting capacity will be significantly reduced. At the very tip of the boom is the boom tip sheave. A sheave is a grooved wheel that holds the wire rope. The wire rope runs from a powerful winch drum at the base of the crane, up the length of the boom, over this sheave, and down to the hook block. The hook block itself contains several more sheaves. By running the rope through the block multiple times, a principle called parts of line is used. This creates a mechanical advantage, allowing the winch to lift loads far heavier than it could with a single line. Finally, from the operator's cab, the nerve center, the operator controls the winch, the swing, and the boom. The load moment indicator constantly calculates forces and will alarm to prevent overload. Every object in the universe has a center of gravity. It is the single imaginary point where the entire weight of the object can be considered to be concentrated. Think of balancing a pencil on your finger. The point where it balances perfectly, not tipping to one side or the other, is its center of gravity. For a simple, symmetrical object like a concrete block, the center of gravity is easy to find. It is right in the geometric middle. But for complex, irregularly shaped loads, finding this point is a critical challenge for any rigger. For a stable lift, the crane hook and the lifting points must be positioned directly above the center of gravity. If the hook is not above this point, the load will tilt as soon as it is lifted off the ground. It will naturally try to shift until its center of gravity is directly beneath the hook. This tilting can be sudden and dangerous. The first lift should always be a test lift, raising the load only a few inches off the ground to see how it behaves. If the load tilts during this test lift, The rigger knows their initial estimation was incorrect. The load should be lowered immediately. The rigging must then be adjusted to move the hook closer to the side that lifted first. Repeat small test lifts until level. This careful, methodical approach is the mark of a professional. Slings are, the vital link between the crane's hook and the load itself. There are three primary types of slings used in modern rigging: chain slings, wire rope slings, synthetic slings. Chain slings are known for their durability and strength. They're excellent in harsh environments where they might be exposed to high heat and sharp edges. Regular inspection of every single link is essential. Wire rope slings balance strength, flexibility, and abrasion resistance. They're made of many small steel wires twisted into strands and wrapped around a core. Synthetic slings are the lightest and most flexible, great for delicate or finished loads. Always use edge protection or softeners on corners to prevent severing under tension. One of the most important and, honestly, often misunderstood concepts in rigging is the effect of sling angles. When you lift a load with a single sling hanging straight down, the tension equals the weight of the load. Rarely do we lift with a single vertical sling. More often, we use 2 slings, 3 slings, 4 slings. This is called a bridle hitch, with slings spreading from the hook to the load. This is where angle becomes critical. As sling angle from horizontal becomes smaller, tension on each sling increases dramatically. Imagine 2 people carrying a heavy box. Close together, arms nearly vertical, each feels their share. Far apart, arms more horizontal. They pull much harder. Crane slings do the same. Take the 1,000 kilograms load, lifted with 2 slings, at 90 degrees, vertical. Each sling feels 500 kilograms. At 60 degrees from horizontal, each sling 577 kilograms. At 30 degrees, each sling 1,000 kilograms. Each sling carries the full load. Total rigging force doubles. The wire rope is the muscle of the crane, the sinew that connects the machine's power to the load. It is an engineering marvel, composed of hundreds, sometimes thousands of individual steel wires working in concert. Individual wires are twisted into strands, and several strands are then wrapped around a central core. That core can be an IWRC for strength and crush resistance, or a fiber core for flexibility. The way the wires and strands are twisted is called the lay. Regular lay is stable. Lang lay is more flexible but can untwist. Like any tool, wire rope wears out and must be inspected meticulously before every single shift. One common removal criterion: more than 6 broken wires in one rope lay in a running rope, or 3 broken wires in one strand in one lay. Discard the rope. Kinking, crushing, abrasion, and corrosion are all signs that a rope is compromised. A rigger should feel for burrs with a gloved hand or rag inspection. Tag and remove any rope that meets removal criteria. A wire rope never fails without first showing signs of distress. It is our job to see and understand those signs before it is too late. Inspect for broken wires, crushing, kinks, corrosion, and abrasion. Take any small signs seriously and replace the rope when required. Of all the tasks a rigger performs, none is more fundamental than determining the weight of the load. Every decision that follows, the crane to be used, the slings to be selected, the rigging configuration, depends on this single, crucial piece of information. The most reliable way to find the weight is to check the shipping documents, blueprints, or the manufacturer's specifications. The weight is often printed on the object itself. This is always the first and best place to look. But what if the weight is unknown? We must become detectives and use mathematics. We calculate the volume and multiply by the material density. For simple shapes like cubes and cylinders, this is straightforward. For a rectangular steel plate, multiply length x width x thickness to get volume. A 10 feet by 4 feet by 0.1 feet plate has a volume of 4 cubic feet. A cubic foot of steel weighs approximately 490 pounds. Multiply volume by density. The calculated weight would be 1,960 pounds. For complex shapes, break the object down into smaller, simpler shapes. Calculate each part, then sum them. Add all section weights to get the total. Be conservative in your estimates. If unsure, overestimate weight to build a safety margin. Accurate calculation is not just about math. It is a core principle of professional responsibility. We have journeyed through the foundational principles of the lifting world. We have seen how a simple hand signal becomes a command of absolute authority, and how a complex machine like a crane becomes an extension of the operator's will. We have explored the unseen forces of gravity and sling tension, and learned that what we cannot see can have the most powerful effect. Every piece of rigging, from the strongest chain to the lightest synthetic sling, is a lifeline that demands our respect and careful inspection. The signal person, the rigger, the crane operator form a small, dedicated team united by a single purpose: to move a heavy object safely and efficiently. Their success depends on clear communication, mutual trust, and a shared commitment to getting every single detail right. There is no room for shortcuts, no place for assumptions, and no tolerance for carelessness. The consequences are simply too great. You will lift the beams that form our hospitals and skyscrapers. You will place the generators that power our communities. You will move delicate artifacts. In your hands, you will hold not just the load, but the safety of everyone around you. Be curious, ask questions, and never stop learning. Approach it with seriousness and with the pride of a skilled craftsperson.